members of national parliaments, and industrial, academic, and institutional representatives of Poland, Germany, UK, Spain, Romania, Luxembourg, Russia, Italy, Austria, France, Armenia, and Belgium. I would like to welcome you all.
Interparlementaire européenne de l'espace, Dominique. Mesdames, Messieurs les membres des assemblées parlementaires, Mesdames, Messieurs les représentants des parlements nationaux, Monsieur le gouverneur, Monsieur le haut représentant belge pour la politique spatiale, Monsieur Picard, Dames en heren, Ladies and Gentlemen, Mesdames et Messieurs. Permettez-moi tout d'abord de vous souhaiter à mon tour la bienvenue au nom des autorités belges qui traitent de la politique spatiale, et cela c'est d'autant plus agréable pour moi que nous sommes ce matin dans ce beau Luxembourg belge.
The acronym stands for European Student Air Orbiter, and is a project which recently restarted from the EISC Education Office, and it was run for about 18 months between 2009 and 2011, and then it was fully reshaped, and now is under responsibility of Alma Space, which is the spin-off from our lab at University of Bologna and the University of Bologna. So it's a joint project run in Forlì, which is a small town close to Bologna. This is a summary of the presentation I will give today. I will just talk about the ESEO project goals and organization. I will talk about the Alma Space Unibo microsatellite mission heritage, just showing how we got this project and how we are intending to manage it. And then I will talk about university network roles, what is the university network and who we involved in this project. And then I will talk about the educational aspects of the project, in particular the lecture and training courses. Then I will briefly touch the ESEO spacecraft design in terms of understanding what the spacecraft will look like and what we'll do. And then I will conclude saying why we need low-cost educational spacecraft for hands-on. The launch is currently foreseen end of 2015, beginning of 2016, depending on the launch opportunity, of course. And as it was already mentioned in the previous video from EISC Education Office, this is the ESEO's mantra, as we say. I hear and I forget, I see and I remember, I do and I understand. This is something which is due to Confucius, and I think it fits very well the idea behind building small satellites, because it means that if you do something which is even simple or not very expensive, but you really learn how to do it. If you just read it on books, I mean, it's something that you saw once and probably you really forget. And the last sentence, which I think is crucial, is that the students make up in enthusiasm. Here they're just waiting for signals, tracking the spacecraft without receiving any signal from space. They were very worried. All people who've been working on this spacecraft for 3-4 years, so waiting to see first signals from space a few hours after launch. This noise is the noise of the radio, which is just giving noise and no signals. That's the enthusiasm I was talking about.
QB50. QB50 is in fact a development of a network of 50 double CubeSats for atmospheric research between 350 and say 100 kilometer altitude in the lower thermosphere. In addition, QB50 is also a framework providing opportunities to do in-orbit demonstration on small platforms like CubeSats for qualification or for testing in orbit of subsystems for future space applications. Typically, we talk about the QB50 allows the raising of the TRL level, the technological research level, providing opportunities to speeding up the qualification in orbit. What is the idea behind this? The idea was, in fact, that we approach the universities worldwide and that we say to them that we provide a dispenser, we provide a launcher, we provide some basic sensors to do some atmospheric research, whereas you, the universities worldwide, develop the CubeSats. Being a standard, it is an interesting job to do. You develop also the onboard avionics required to do the measurement techniques, the downlink system, the battery, the solars, and we give you the sensors required for swarm measurements, network measurements for atmospheric science and research. And so this project was started 2 years ago, and you see here a view graph on a typical double CubeSats. Again, one part is the so-called science unit, the other part is the functional unit. Way of doing research worldwide, stimulating the universities, not only for in-orbit demonstration and science measurements, but also the downlink systems, the network, the standardization, the true science analysis with these universities. So it's a unique project which is the beginning of a new area of, using space for small-scale research. Exactly the topic of this. The remark I wanted to make is that, and I was personally a little bit surprised that none of the comments came in this direction for small sats, and that was access to space. Because the big issue is not CubeSats and small sats, but the big issue is how to bringing them up there. And of course we have with ESA the very nice opportunity for Vega and the ARTA flights and the new opportunities to have some passenger flights on CubeSat, which is very nice, very beautiful. But the real breakthrough will come if we have a cheap and frequent access to space.
400 square meters of photovoltaic panels.